This is lecture 16 on urban transportation planning. We will continue our discussion on modal split analysis in this class. Let us recall what we did in the previous class briefly, so that there is continuity of the discussion. You may recall we mainly discussed about attribute specific utility function in mode choice analysis. The reason or the advantage of attribute specific mode choice functions is that it would be possible for us to introduce any mode into your utility function process. You will have a single utility function and all modal characteristics can be incorporated easily. That is the advantage of attribute specific utility functions. In that context, we discussed about some problems related to the utility function, mainly with regard to the constant term, how to account for the value of the constant term when we deal with a set of alternative modes. Then we discussed about incorporating the effect of trip specific advantages for a particular mode in the utility function. We also discussed about the possibility of incorporating the socio-economic characteristics of travelers in the utility function. And finally, we discussed about the randomness of the utility itself, because individuals perceive utility of modes in their own way. That is how utility of a particular mode for different individuals happens to be different. We cannot fix a constant value as utility for a particular mode, it varies from individual to individual. Hence it is appropriate to bring in this variation by introducing some randomness in the utility function. In that process, we discussed about the introduction of a random term with the symbol epsilon, and finally we discussed about the possible distribution for epsilon. Before we proceed further in our discussion, let us try to check ourselves whether we have captured the essence of the previous lecture by posing a set of questions. I hope some of you will be able to answer these questions. The first question is this: what is the hypothesis behind the choice abstract theory? Hypothesis behind the choice abstract theory. Any suggestion?
The choice of a particular mode depends upon the attributes of it, attributes of a particular mode.
Yes.
Based on that, people will select.
Fine, that is the result or effect of choice abstract theory. The hypothesis can be explained in an abstract form as follows. The choice abstract theory is based on the hypothesis that when making choices, people perceive goods and services indirectly in terms of their attributes, each of which is weighted identically across choices. In that context only, we discussed about choice of cell phone services based on a set of attributes, choice of car. For example, if the engine size is 1.2 liters for Tata make or Hyundai make or Maruti Suzuki, we do not differentiate between makes. When the engine size is same, we perceive that the utility of the car of this engine size irrespective of the make is same. That is the meaning implied here. We depend mainly on attributes, not specific to a particular good or service. Clear? So this is the hypothesis behind the choice abstract theory. Next question is this: how are the constant terms in the utility functions which are meant to capture the effect of variables that are not explicitly included in the model, weighted across modes in attribute specific approach? How are the constant terms in the utility functions weighted across modes in attribute specific approach? Why should we weight the constant terms across modes? Because we have only one general function incorporating all the attributes into it, and only difference we want to make is based on the constant term which stands for the unexplained part of the dependent variable, right, and that if not changed will have the same effect for all the alternatives, which may not be realistic. So, the unexplained part will be different for different alternatives. We want to bring in that difference. How do we do that?
Taking one as base function and explaining in terms of the base.
Good. Taking one mode as a base mode, we make the constant term to be 0 for the base mode, and then we fix the relative values for the other modes. That is how we manage this particular situation. Then it facilitates variation of utility of different modes, even though the complete variation is not explained by the set of attributes considered for the utility function, right. So, this is done by utilizing any of the modes in the choice set as the base mode. Once you do this, you will be able to differentiate the extent to which the unexplained part is considered in the utility functions for the different modes. The next question is this: how to incorporate trip related attributes that changes the utility of modes in attribute specific utility functions. First, we need to understand that trip specific attributes may change the value of utility of a particular mode. Do we agree with this statement? Unless we agree on this, we will not be able to answer this question. Can specific trips change the utility of a given mode? Yes or no? I think most of you respond by saying yes. So, trip or the nature of trip can change the level of service or utility of a particular mode. In this context only, you may recall that we discussed about trips towards CBD, trips connected to CBD and trips not connected to CBD. In certain specific situation, trips connected to CBD may have added utility for transit service. Because of restriction in parking in the CBD areas, the personal modes become less attractive, utility gets reduced. Now, the question is, how do we account for this change in utility of a particular mode when the trips are of different nature? What is the technique adopted for this purpose? You may recall we discussed about binary variable technique, right. So, when a trip is connected to CBD, you assign value 1 for that particular variable, otherwise 0. So, that is how we incorporate this aspect also in the attribute specific utility functions by dummy or binary variable technique. That is the answer for this question. That clear? The next question is this: how to incorporate the variable reflecting the economic characteristics of travelers in utility function. we would like to incorporate the effect of economic status of travelers in the utility function. It is essential because the choice of mode by travelers depends on their economic status. How do we do this? Any suggestion? You may recall that we discussed about expressing travel cost as a percentage of the income of the traveler. What is the purpose? Once you express the travel cost as a percentage of income, for a higher income group the percentage is going to be very small. For middle income group the percentage will be having some medium value, low income group the percentage is going to be very high. That reflects the pinch of purse experienced by the different groups of travelers based on their economic status, isn't it? So that is a very important factor affecting mode choice. So this has to be incorporated by this particular methodology. So this is the answer for this question. By representing travel cost as percentage of the income of travelers, do not give absolute values, represent it as a percentage of income. This implies that you are going to categorize the travelers into different income groups while developing utility functions. That is the point made here. In that context, in the previous class I also mentioned about the possibility of introducing other social and demographic factors in the utility function, like the effect of age in mode choice. What is the technique adopted for introducing the effect of age in the utility function? How do we do that? Use binary variable technique, fix an age limit. People below that age will have some value in the binary variable, and above that age limit will have another value, isn't it? Or if you want to have 3 categories, it is possible. You have 3 different numbers for the 3 categories of people based on age, right. So that is how we should think of introducing all possible factors that might influence mode choice. Why utility or disutility of a travel mode needs to be treated as a random quantity? Since we have discussed about this just now, I thought we will straight away look at the answer. The reason is this: because the level of utility or the service of a mode of travel as perceived by travelers varies significantly between individuals, right, based on their personal characteristics. That is why there is a need to treat utility as a random quantity and not a fixed quantity. On this basis only we proceeded to formulate a function for utility incorporating this randomness, isn't it? Proceeding further, we can say now the utility that a traveler in zone I receives when choosing alternative J can be written as follows, as we have seen in the previous class. Uij is equal to Vij plus epsilon ij, where Vij is the average traveller's utility assumed to be constant for a given mode given by an utility function, and epsilon ij is the uncertain or random part of the utility function specific to individual travelers. And then we were discussing about the possible functional form for epsilon ij so that we are able to quantify Uij ultimately to analyze the mode choice. And in the process of discussion we found that several researchers have recommended Gumbel or double exponential distribution as more appropriate distribution for epsilon ij. This is based on considerations of simplicity in analysis and possibility of getting closed form solution. So based on this assumption only we found that it is possible to treat utility as a random quantity and still quantify utility for various alternative modes. To understand the concept little more clearly, let us consider a very simple situation involving mode choice between two modes, mode 1 and 2, wherein 40% of the travelers make use of mode 1 and how to express this mathematically. We have a situation where there are two alternative modes available and 40% of travelers make use of mode 1. Can you express this situation mathematically? This is how we can mathematically express the situation. Probability of choice of 1 is 40 by 100. 40% of people make use of mode 1, so that will be equal to 0.4. Probability of choice of mode 1, here it is 0.4, and we can also write the same thing as 40 divided by 40 plus 60, implying the share of two modes, that is what is taken in the denominator, isn't it? 100 implies 40 plus 60. So in general, if you take the 40% as utility of mode 1, you can say U1 to be equal to, or probability of choice of mode 1 is equal to U1 divided by U1 plus U2, isn't it? So if there are m alternatives, we are going to write probability of choice of j, for example in general, will be equal to Uj divided by sigma k is equal to 1 to m Uk, isn't it? Sum of utility of all the modes. Agreed? And when you assume Gumbel distribution for epsilon ij and try to derive an equation for probability of choice of a particular mode, you will get a similar formulation but little differently. I will directly give you the result of the equation or the function. Probability of choice of j is given as e power Vj divided by sigma k is equal to 1 to m e power Vk. What is the difference between the previous equation and this equation? Instead of u, we are introducing e power v both in the numerator and the denominator, right. So based on the probability aspect or probability state theory, if you derive a formula in general for probability of choice of any mode or a given mode, based on the assumption that epsilon ij follows Gumbel distribution or double exponential distribution, we end up with this result. The derivation of the formula is beyond the scope of this particular course, so that is why I am not bringing in the derivation part, which needs quite a good amount of background knowledge in probability and statistics. Okay. Those who are interested can refer any one good book dealing with probability of choice of alternatives. So, you will be able to get information about the derivation of this equation, right. What I have given here is just the result, but you should appreciate that it is similar to what we have seen. The only difference is when you derive, we find that it is possible to incorporate the randomness without bringing in epsilon ij in the equation. What you use is the fixed part of the utility, a Vj and Vk. That is the interesting aspect of it. If you go through the derivation process, you will understand how epsilon ij gets eliminated when we transform into this particular functional form, right, where Pj is a probability of choice of alternative j and m is the number of alternative modes including j. So, suggestion made here is we have to take this equation for granted, right, and this equation is also named as logit model of mode choice. Why it is named as logit model of mode choice? You may recall the shape of the curve that we assumed for distribution of epsilon ij. That curve is also named as logistic curve. Another name given by researchers is a logistic curve. Since logistic curve is taken as a basis for the derivation, the model itself is named as logit model of mode choice. Okay. So, logit model of mode choice is nothing but this equation. Pj is, or P of j is equal to e power Vj divided by sigma k is equal to 1 to m e power Vk. The above is known as a logit model of mode choice. Now, let us just see how to apply this logit model for a given situation. We will directly take up a small numerical example and see how logit model can be applied to analyze mode choice. Clear? Let us consider this example. A calibration study resulted in the following utility function. Vk in general is found to be equal to Ak minus 0.025 x1 minus 0.032 x2 minus 0.015 x3 minus 0.002 x4, where x1 is equal to access plus egress time in minutes. I think you know clearly now what we really mean by access time and egress time. Time to the transit station is access time, time from the transit station to the destination is egress time. X2 waiting time in minutes, X3 line haul time in minutes, line haul time or in vehicle time, both the same, and X4 out of pocket cost in rupees, about which we had enough discussion about what we really mean by out of cost expenditure in respect of transport. So, please note that all these variables are related to mostly time and the last one is related to cost. So, here utility of a given mode has been decided based on a set of time components and the cost, only two attributes mainly, but the first attribute is categorized into three types. Why categorization into three types? Why not take the total time? Yeah.
Because each and every mode has different timing.
Each and every mode.
mode has a different time.
Okay.
So it has to be classified so that the mode can be easily analyzed.
That is a point, because when we consider different alternative modes, these components are going to be different. In certain cases you may find some component may be even 0. For example, if you take personal mode, there is no waiting time. If you take transit, there is waiting time component. That is why we need to split the journey time into different components, so that the real utility of different modes are brought into your utility function, right. So this is the calibrated utility function. Why negative sign for all the variables? Because the author has treated these utilities as really disutilities. They spend time, they spend money, why not term it as disutility? In that context you get negative sign for all these variables, right. So this is the calibrated utility function, and the zonal trip interchange in the target year is 5000 percent trips per day. Please note, this is zonal trip interchange between a pair of zones. We do not consider the entire urban area, it is specific to a particular travel market. Okay. During the target year, trip makers will have a choice between motorized two-wheeler and city bus. This targets a particular socio-economic group where they have specific choice of only two alternatives. The target year service attributes of the two competing modes have been estimated to be as follows: target year or horizon year. These are the values of x1, x2, x3 and x4 for the two modes. For motorized two-wheeler, x1 is what? As per our initial understanding of the variables, x1 is access and egress time. Okay. 5, the unit is same in both the cases, you can take it as 5 minutes. x2 is waiting time, x3 is line haul time, and x4 is the actual travel cost in rupees. So obviously waiting time is 0 for motorcycle and line haul time is 20 minutes and cost, let us say, rupees 10. It is a zonal pair travel, you can consider this as the cost for one trip as indicated here. For city bus, x1 access egress time is more 10, x2 there is waiting time 15 minutes and cost, no, the third one is line haul time is 40 minutes and cost is less, about half of the cost implication with motorcycle, right. And we have to find out what? We have to get utility function or the value of utility for the two modes, and then evaluate or estimate the probability of choice of motorcycle as well as bus. That is our ultimate objective. And of course we can calculate a few other things also, that is what is asked here. Assuming that the calibrated mode specific constants are 0.00 for motorized two-wheeler, which is taken as a base mode, that is why 0, and minus 0.10 for bus mode, apply the logit model to estimate the target year market share of the two modes. Market share is asked for, okay, how many travelers out of the total will use motorcycle and how many will use bus has to be estimated finally, and the resulting fare box revenue of the bus system. That is the last question to be answered. What will be the collection for the bus service? Fare box revenue. Let us see how to go about doing this exercise. Using the utility function, we have got the results here. The results are shown here. Utility function is given to us earlier, right? Substitute the values of x1, x2, x3 and x4 corresponding to motorcycle, right? Then you get the utility shown here as Vm to be minus 0.445, or disutility related to motorcycle is minus 0.445, and using the function, if you calculate disutility for bus, it is minus 1.440. Is that clear? We have the equation given earlier. Substitute the values of x1, x2, x3 and x4 corresponding to the two modes, and you get the values of utility for the two modes. Are you able to appreciate this point? Just I will go back to the equation. This is the equation given, calibrated utility function, and if you substitute ak to be 0, right, for motorcycle, and substitute the values of x1, x2, x3 and x4 corresponding to motorcycle, which is 5, 0, 20 and 10, you get the value of Vk, is not it? So, that is how we have got values of Vk named here as Vm for motorcycle as minus 0.445, and for bus named here as Vb as minus 1.440. Utilities are calculated now. Of course, this is a fixed part of the utility, and then substitute these values in the logit model, isn't it? You can get probability of choice of motorcycle as 0.73 and probability of choice of bus as 0.27 obviously. Are you able to appreciate this point? How do you get these probabilities? We have the values of Vm and Vb, isn't it, and use the logit model which you have seen here. Probability of choice of motorcycle Pm here is going to be e power Vm divided by e power Vm plus e power Vb. The values of Vm and Vb are known, so you can get the value of Pm as well as Pb. If you want to estimate Pb, Pb is equal to e power Vb divided by e power Vb plus e power Vm, isn't it? That is what we do to get this result. That is how we get probability of choice of motorcycle as 0.73 and probability of choice of bus as obviously 0.27. We know the total number of trips. Knowing the probability, you can calculate the actual modal share, isn't it, by multiplying the total number by the corresponding probabilities. So, the market share of each mode is then Qij m, because it is origin destination specific. So, you can say Qij by motorcycle m is equal to probability value is 0.73 and total number of trip interchanges are 5000. So, actual modal share is 3650 trips per day made by motorcycle between this particular set of origin and destination, and Qij by bus 0.27 into 5000, that is equal to 1350 trips per day, right. From this information, can we calculate the fare box revenue? Total number of travelers is known, that is what is meant here as Qijb. Modal share is known to us, so many trips. These trips are person trips, not vehicular trips, person trips. We are dealing with person trips. What is the cost of travel by bus? Out of pocket cost, that was indicated as X4 in the data, which is 10 for motorcycle and 5 for bus. Okay. So, this number into 5 will give you the fare box revenue. The fare box revenue estimate is 1350 trips per day into rupees 5 per trip, that is equal to 6750 rupees per day for the bus operator. So, it is a very simple example, but at the same time gives you a revealing application in practice. So, this is what we do by way of applying the logit model of mode choice. We will continue the extension of this example as example 2. Introduction of a new mode. Let us say we are working the mode choice scenario for a horizon air condition, right. Now, it is desired to examine the effect of introducing a rapid transit, right, in the city of example 1, the previous case where we considered 2 modes. A related study has projected that the service attributes of the proposed system, rapid transit system, for the trip interchanges under consideration between the same zonal pair will be as follows, as given here. X1 for rapid transit is going to be 10. What is X1? Access and egress time, is not it, is going to be 10 minutes. X2 is waiting time, is going to be on the average 5 minutes. X3 line halt time is going to be 30 minutes. You may recall line halt time for bus was 40 minutes, whereas here it is slightly less, and it is estimated to cost about 7.5 rupees per trip, slightly more than bus, but less than motorcycle, is not it. So, these are the parameter values or values corresponding to various attributes that we have brought into our utility function. Now, we have how many alternatives after introduction of rapid transit? 3 alternative modes. There will be 3 utility values, and we need to calculate 3 probabilities and then estimate the modal share, right. And this is another important information given. Based on professional experience, the mode specific constant for the new mode is estimated to be minus 0.06. This is also required because we need to accurately estimate utility for this mode. This minus 0.06 is based on the same assumption that motorcycle is treated as a base mode, right, and there is no change in the constant term considered for bus. Okay, without making any change in those constant terms, it is found by experience that the constant term for this mode can be taken as minus 0.06. Okay. Now, this is the question. Find the market share of the 3 modes that will result from implementing the rapid transit proposal and the effect on the revenue of the public transportation authority, which operates both the city bus and the rapid transit system, which is somewhat peculiar to our condition. Here rail and bus services are operated as separate entities. There is not even any coordination between these two modes. That is the way we operate our transit services, which is ultimately becoming unfriendly for the users. It is not really user friendly. If these two modes as indicated here are operated by a single public transit authority, there will be several advantages. Managing the system will be much easier in the operator's point of view, and in the user's point of view, users can treat both these modes as a single mode. As far as travel is concerned, users can be given a single ticket and they can make seamless travel, and waiting time can be reduced because the same operator is operating both rapid transit as well as bus service. They can schedule the bus services in such a way that when the bus arrives, the waiting time is just sufficient to go and take the rapid transit service, train service. All these things are possible. That is what is happening in most cities of developed countries. Single ticketing system and all transit services under single authority. Even though practically operators could be separate entities, as far as revenue collection is concerned, it is done by a single authority and then shared by the operators based on the actual demand for each of these modes, as well as level of utilization, maintenance commitment, and so on. That is how this transit system is being operated in developed countries. Hopefully we get such a situation shortly in our country. People are talking about, at least conceptually, with regard to integration of all the modes and developing a single authority for managing transit system and so on. Right, getting back to the question, let us get the solution as follows. Assuming that the attributes of the existing modes will not be affected by the introduction of the new mode. Why this assumption? Assuming that the attributes of the existing modes will not be affected by the introduction of the new mode. What are the attributes of the existing modes which are of our concern? The attributes we have considered are x1, x2, x3 and x4, okay. And these values are assumed to remain unchanged even after the introduction of a new mode, which need not necessarily be true in all the cases. Which are the attributes of the existing modes that are likely to change because of introduction of a new mode? Any response? Will there be a change, for example, in x1 of the modes, other two modes, when you introduce a new mode? X1 is access and egress time. Will there be any change when you introduce a new mode? May not be any change. X2 is waiting time. Could there be change when you introduce a new mode? Waiting time of the previous, the already existing modes. Are they likely to, is there a possibility of change in the waiting time for the other two modes? May not be changes unless the new mode is also introduced on some routes in parallel with existing bus service, for example. Then there will be a split in the demand and the bus operator might choose to operate or reduce the frequency of service, which may lead to increased waiting time, isn't it? So there is a possibility of x2 of the existing modes changing because of the introduction of a new mode. How about x3? line haul time may not change much. X4, the cost, if the introduction of the new mode creates competitiveness among the modes within the transit system, then to compete for the share of the market, the bus operator might reduce the fare, is not it? Competition gets developed. So, there is a likelihood of change in the value of X4 for the existing modes, right. But here we assume that all these attributes remain unaffected for this case, right, after the introduction of the new mode, clear. And based on this assumption, we can quantify utility value for the different modes. Here we have 3 modes. So, we estimate utility values as Vm to be minus 0.445 and Vb minus 1.440 and VRT rapid transit minus 0.935. You can see the utility value stands between motorcycle and bus, right. Then let us use the logit model of mode choice and find the probability of choice of each of these modes. I will be giving the result directly. Proceeding as before in the previous example, we can get probability choice of motorcycle to be 0.504 and the actual market share will be 2520 trips, and probability of choice of bus will be 0.187 and the market share of bus will be 935, and probability of choice of rapid transit will be 0.309 and the market share will be 1545 trips, right. Now, we get a very clear picture of the share of the market by the 3 alternative modes. Now, to answer the final question, the revenue for the transit system operator, we need to multiply the market share by the corresponding cost. Bus share is 935 trips and cost is 5 rupees. So, 935 into 5 plus market share of rapid transit 1545 and the corresponding cost is 7.5 rupees. So, total is 16,262 rupees 50 paise per day. That will be the fare box revenue for the transit system operator involving both bus and rapid transit system. This is for a horizon year situation, that is very important, but we are using a calibrated utility function, is not it. How the utility function is calibrated? How do you calibrate utility function?
Using any previous data.
Using the base year data. You have to collect data initially to calibrate any function, right. How do you collect the data and use the data for calibration of utility function? On the left hand side you have utility of a particular mode, is not it. On the right hand side you have a constant term and then values the x1, x2, x3 etc., representing the different attributes of alternative modes. In practice you will be collecting data pertaining to all the independent variables x1, x2, x3, x4 and so on. Also you will know the value of V1, V2, V3 etc. for base year condition, is not it. How do you get the value of V1? you will know the market share of different alternative modes, right. Let us say 30% of people are using mode 1, 40% mode 2, another 30% mode 3. See, this modal share reflects the utility values of these modes, is not it. So, once you know these values, it is possible to calibrate any utility function. Maybe later on we will discuss in detail about calibration of such models. To summarize what we discussed in this class, we try to understand how we get the logit model of mode choice from the principle that the utility function is a random quantity. Based on the assumption of randomness, we have seen that following a systematic derivation procedure, it is possible to get the model that we have just now seen as logit model of mode choice. And we saw two numerical examples in the application of logit model of mode choice. The first example involved two alternative modes, and we understood clearly how to estimate the market share for two alternative modes, and of course to calculate the fare box revenue for the transit system. And we also discussed about a situation where a new mode is introduced and the procedure of applying the logit model of mode choice in estimating the market share for the different modes, including the possible newer mode that will be introduced in the horizon year. With this, we will conclude our discussion for today. We will continue on this subject matter in the next class.